Okay, so the next test we're going to do is your test 13.2A. This will include your introduction. Okay, introduction, then the questions in exercise 13.2, question B, 1, 2, 3, and 4. All this you'll find from textbook pages. Okay, introduction of the chapter from pages 229 to 233. 233. We'll start with the introduction. Right along with me as we do. Okay, introduction is the formulas. So the solid that we're going to discuss in this chapter is a new one. Previous chapter we've done the cuboid and the cube. So it is the third solid, which is the cylinder. So let us define this cylinder. As a solid formed by is a solid formed by, okay, solid formed by stacking circular sheets. According to your textbook, stacking circular sheets. Okay, circular sheets of paper. Let us say paper vertically. This is important, vertically. Okay, vertically upright. Upright. That is, the meaning is right angles to the circular base. Right angles to the circular base. Okay, that's the definition, basic definition. So that means if you take circular sheets of paper like this, circle, and put one over another, that is called stacking. If you put it one above other exactly, that's called vertical. So if you put sheets of paper like this, those are sheets of thick paper like this in a manner that is twisting, let us say, like this, so that the first sheet, second sheets are not vertical, but they are twisted like this. This is not a, this is, you can draw the figure also, not a right circular cylinder. It is not a right circular cylinder. Okay, then what is the right circular cylinder or cylinder? It is when you place them one over the other, so it is exactly 90 degrees to the ground base, like this. Then such is called, this is the one. This is the right one, or right circular cylinder. So let us say this is figure 1, then okay, then just give it like that. So this is the right circular cylinder. Simply put this container having here, see, this is the cylinder standing upright. Okay, this, you can see the shape. So both ends have circle ends like this at the top circle, at the bottom circle, at the top, this side if it is covered circle. So the radius of that circular base, or the top radius, both of these are called the radius of the cylinder. And the height from here, measurement means measure from here to here, is called the height of the cylinder. So the two basic dimensions of a cylinder are its radius of the circular ends, or the height, or this is also called the length or height. When the cylinder is made to fall in on the ground like a pipe, that's called length. When it's upright like this on the ground, it's called height. Okay, this is our basic definition. Now let us go and discuss the formulas. So there are two basic formulae related to cylinders in this chapter. Formulas, plural is formulae. The first one, let us say. To discuss this, let us take a cylinder. Let me just do it in a practical manner. This is say figure, let us say 1. Then you cut open, write everything along with me, cutting it open vertically. Vertically means that what they mean is this one. Suppose this is the sheet of paper. This is the cylinder rather. So this is now exactly in the form of cylinder, circular end if it was covered with a paper. So this here, okay, this here is called, if you touch the surface, it's curved. So this is called curved surface area. If you touch this end which is closed by paper, supposed to be closed, then it's flat, so there's not curved surface. And the other end also is not curved. Only the curved surface area is only this portion, the side portions. So as you cut it open, the curved surface area or the lateral surface area becomes like this flat, becomes a rectangle, that means. So the curved surface area has turned into a flat rectangle, figure 2, let us say. Now you know that as you cut it open, here, this length from here to here, figure 2. Before you cut it open, when it was in a curved form, just listen carefully so that you understand the formula clearly. So here, before you cut it open, it was like this, and this portion here from here to here was actually this one, see. This portion, if you would imagine this circular, means the distance covered in going one time around this circle, which is the circumference of the circle, one time distance round. So when it was cut open also, the distance will not change. So this was curved. This was the circumference, and the circumference of circle is 2 pi r. If this cylinder had a radius of r, so if this cylinder radius is from here to here, r, and this is the height h, then this was 2 pi r. And after cutting open also, this h, if this 10 centimeter will remain 10, means height will remain same. So we are going to derive the formula for curved surface area, or we call it also as the lateral surface area, because when the cylinder is standing in the normal position upright, this curved surface is actually the side, and the side areas like the side walls of a room are called, 4 walls are called lateral surface also. So lateral surface of a cylinder is the curved surface area actually. So we call it as curved surface area or lateral surface area of cylinder. We are talking about figure 1 is now converted to area rectangle in figure 2 is the same. This curved surface here is the flat rectangle surface in figure 2, because this curved surface was derived from the same cylinder. That way we know that area of a rectangle is length into breadth. The length is this portion, the breadth is this. The length before it was cut was circumference, this is the length. The breadth of the cylinder is h. So formula for curved surface area of a cylinder is 2 pi r h. You use this figure cut open, then draw these steps so that we understand how the formula 2 pi r h came about. But once you understand, we just have to memorize curved surface area or lateral surface area of any cylinder is always equal to the last one only you memorize 2 pi r h. In your first test 13.1, you have to fill it up blanks, curved surface area of a cylinder. with this one. Okay, so you have to memorize. Having done that, second formula, let's go to the second formula. Using the same figure, write it up to there, and the second formula is number 2. Let us use the same figure. Total surface area, or simply surface area of cylinder, any cylinder for that matter. Let us say we're taking figure 1, will be equal to, look here now, this is the cylinder, let us say. Then this is the curved surface area or lateral surface area plus this circle area. So one circle, then this is supposed to be closed technically, so second circle, so we have to write 2 circles area. So that is the total surface area. See, curved surface area plus first circular base and the top circular, everything is covered, is the total surface area or surface area. So that is the formula. Just now we derived the curved surface area of any cylinder is 2 pi r h plus area of a circle, we know even from class 8-9 also, pi r square. So there are 2 circles, so we multiply the area of one circle to 2. That is the total surface. So if you take out common 2 pi r from both, we're going to get into, and here inside the bracket only h left, because 2 pi r is outside. So 2 pi r plus here 2 pi r into 2 pi r out, so one more r there, so r square. So the formula is 2 pi r into h plus r. So the 2 basic formulas we're going to use in this exercise 13.2 curved surface area or lateral surface area of a cylinder is equal to 2 pi r h, and total surface area or surface area of a cylinder is 2 pi r into h plus r. So keep that in our minds and memory properly, right? Once we're done with this, we'll go to the exercise. Let's go into the exercise here. Okay, so I think time is there. Okay, so B1, let us start with exercise 13.2 B1, page 232. The curved surface area of a cylinder is of height 14 cm is 88 cm square. Find the diameter of the base of the cylinder. Let's draw a representative cylinder therefore. And the diameter means from here to here. It's called diameter. Radius is from here to here. Diameter is unknown, we have to find. The height is given. Measurement from here to here is called height. We learned that just now. 14 centimeter. So let us write down here for the given cylinder. For the given cylinder, r equal to question mark, that is the radius of the cylinder is unknown. Here even this r is unknown. Diameter therefore is not known, because diameter is related to radius. Height of the cylinder is 14 centimeter. Only this much is given. But the question is saying, so let us write it down. Since question says curved surface area of cylinder of height 14 is 88 centimeter square, that means question is saying its curved surface area is 88 centimeter square according to the question. So therefore we can write curved surface area formula 2 pi r h. We learned that just now. This one is means equal. Curved surface is given 88 centimeter square. This is something we totally got from the question itself. Next step, let us replace it. However, pi value is not given, we're going to use 22/7. And r is here not given, so we just write that. R into h is given here 14 centimeter, then equal 88 centimeter square. So 7 1s are 7. We clearly see this is cancelling. 7 2s are 14. So if we keep this r on the left side without shifting, and this 88 centimeter square also kept on the right side without shifting. The rest on the left side, 2 and 22 and 2 broad, all of them on the numerator, so will shift to the denominator when you shift to the right side from the left. So 2 into 22 into 2, all of them come down, and even centimeter come down. So this centimeter to the power 1 and 2 minus 1 gone, so still 1 centimeter left on the numerator. Then 2 1s are 2, 2 4s are 8, 2 4s are 8. Again, we can cancel this 2 1, 2 first maybe, 2 1s are 2, 2 2s are 4, 2 2s are 4. And 22 1s are 22, 22 1s are 22. So we're left with radius equal to 1 centimeter. See, 1 centimeter. So therefore, question is asking the diameter. So its diameter, the diameter of the cylinder diameter is always twice the radius. So 2 into 1 centimeter, as we got R1. 2 1s are 2 centimeter is the diameter of this cylinder. I hope you're getting it right. And let's go to B2. It is required to make a closed cylindrical tank. So cylindrical tank has to be made. Both the base and the top are closed. Means with dagna like that. Height 1 meter. So from here to here 1 meter. And the base diameter 140 centimeters. So diameter radius is from here to here, but diameter is from here to here. So that is 140 centimeter. Close at both ends. This kind of cylinder we have to make with a metal sheet. How many square meters of metal are required for the same? So here, for the cylindrical tank, we can write like that. For the given cylindrical tank, if you like to add, its radius R will be the diameter divided by 2 centimeter. They are saying convert to how many square meters. So let's keep that in mind. 70 centimeter is the radius in centimeter, but they're asking in meter. So let us change the meter. So centimeter here. So moving without counting the first one, second one, 2 places to the left. So we're changing small to big. So sorry, small to big. So divide. So 70 has to be divided by 2 places. So one place is 10, second place 10, so 100. And centimeter will disappear, meter will come in. 1, 2. So these two cancelled, and then decimal is here now. 1 0 means decimal, because of division by 0, will move to the left. Multiply means move to right, but divide means move to the left. So 0.7 meter is the radius in meter. Then the height is already okay. Height, this is the radius of the cylinder. The height is 1 meter. So this is the height of the cylinder. Okay, so once we're through with that, then we can write down, since starting from the beginning, we're going to make closed cylindrical tank. So since it is closed means both ends, we understand both ends. Therefore, last part, how many square meters of metal sheet? So meter squares means area. Square is area. Meter squares of sheet required will be, closed means its total surface area, or surface area means total surface area of the cylindrical tank. So we know the total surface area formula is 2 pi r into h plus r. We learned this a moment ago. So they'll give you 2 into 22 by 7 for pi. R here, as you can see here, is 0.7 meter. So we write 0.7. H is 1 and R is 0.7. Area means we can just put 1s at the back, meter square. Then we can cancel this. 7 1s are 7. 7 zeros are 0. 0.7 1s are 7. So 2 into 22, 44. 44 into 1, 44, and 0.1 means 1 decimal place. So right from here, extreme right, shift left, 1 decimal place. So when we will multiply this 3, we're going to get 4.4. 2 into 22, 44. 44 into 1, 44. Because of 1 decimal place after multiplying, we shift from extreme right to the left 1 place because there is decimal. 1 plus 1, 0.7 is 1.7 meter square. So 4.4 into 1.7 is our answer. 4.4 into 1.7 multiplied means 7s are 28, 2 in hand. 4 ones are 4 plus 2, 6, then same number, so 8, 6 again. So 8, 14, 1 in hand, 7. Decimal places, as I've been saying, is on the right of the point. So 1 place here and 1. So left are not decimal, they are called integral. On the right of point are called decimal. 1, 2 places. So right from the extreme right, 1, 2. So it will come between 7 and 4. So 7.48 meter squares of metal sheets will be required to make this closed cylinder. Okay. We'll continue in 3 and 4 in the next class.